And Aurelian thought this wasn't going to be an interesting presentation, so I had to give it a very long and grandiose title. A deep dive into the evolution of a Lustre feature. All right, so I thought this is kind of an interesting topic because I can give a little bit of a history of to why a feature is the way it is, and this is not necessarily specific to this feature, but a lot of the features developed in Lustre are somewhat historical anachronisms, so I think this is a little bit illustrative of that. Okay, so we will start with the bad old days in Lustre 1.4, where if some of you may remember, there was LMC, where you ran the LMC tool to generate an XML file. You would then have to distribute the XML file produced out of band via some other mechanism to all of your nodes, including your client nodes. And then you'd run lconf on all the different nodes in order to start up the different OBDs that actually made up of Lustre. lconf in turn called lcontrol to do kind of these low-level commands, config device, etc. So this was an annoying and an error-prone process, to say the least. So things got a lot better with Lustre 1.6, where we introduced the MGS and the MGC. And the way this basically works, when you first start a server, the MGS would send information, sorry, the MGC, which is started on every node, sends information to the MGS about the node, in other words, what the storage is on that node and whether it's an OST or not, whether it was formatted that way. And then the MGS in turn creates the configuration file. The MGS also adds, if for instance you start an OST, the MGS adds to two different log files, the MDT and the client log file, information about that OST. So it used to be that all this information was generated in one vast file back in with LMC. Instead, this is generated, MGS generates the file incrementally as different servers start up. So interestingly though, behind the scenes, we kept this same L-control format at the bottom. That's still kept, although now in this case it's kept in logs on the MGS. All the servers and all the clients, when they first start up, talk to the MGS and get those config logs back, and actually ends up parsing these commands in the same way. So they still use these L-control commands to actually set up the OBD devices. And we also use a mechanism in order to provide updates, which is the LDLM, which basically we create a lock for the configuration, and the configuration lock is called back in order to notify all of the different nodes in the Lustre file system that they should update the configuration log. Then they read the updates in those incremental logs that I mentioned and change their configuration accordingly. So, okay, all fine and dandy. Let's talk specifically about parameter updates. With 1.4 and previous, you would change proc files on an individual case-by-case basis. There wasn't a way to kind of generally set these things. So with 1.6, we added this, well, 1.6, we actually kind of wrapped that same proc file configuration syntax with a L-control set param command. And I'll get into the reasons why we did this in a minute. And then we added a way to set those parameters permanently using L-control conf param. And what L-control conf param does, it adds now these lines to those same log files that we were talking about before. So why? Why do we change the syntax of this slashes dots? And you notice the name here, obdfilter.testfs.syncjournal, matches the slashes above in the proc files. But the conf param command doesn't match this at all, even though this is the same thing you're changing. Why did we switch these things around? Well, this was my fault. I'm sorry. So why? This was back in Sundays, and there were thoughts that that we were going to port Lustre to more platforms than just Lustre, than just Linux, and platforms other than Linux don't have proc. So the idea behind both the L-control set param and the conf param was that, hey, let's stop using proc directly and let's use actual Lustre commands, and let's, as long as we're going to change it, as long as we're getting away from proc, why don't we reorganize these commands to fix things? So for instance, you can see that obd filter, which is the current name of the module that is, represents an OST, I changed to OST because that's what everyone calls it, an OST. No one calls it an obd filter. So there were various things like that. And also the hierarchy here, where you would specify a file system and then a subcomponent of the file system. We thought, well, this makes more sense rather than one based on the module definitions that Lustre happened to have in Linux. So those were kind of the two big reasons to change this around. Unfortunately, we never moved to Solaris. Well, fortunately or unfortunately, it doesn't matter. We never moved to Solaris, and people continue to use proc. And so now we have this confusion of different nomenclatures for representing the same thing, either in a temporary or a permanent form, which is silly. So, so let's fix it. Let's make the names the same. Well, other problems. So the names don't match. We would like to be able to use globbing characteristics like stars and other question marks, so that you can choose a number of OSTs rather than, if you also notice here, if you wanted to change the parameter for an OST, you kind of have to specify the entire OST number. Well, that's great, except you have, whatever, 1,000 OSTs. This starts to get kind of a long configuration file. So it would be nice to be able to do globbing. Also, confusion abounds in that the conf param parameters actually need to be sent to the right configuration log. As I mentioned before, maybe glossed over a little too quickly, that there are per OST logs, and there's a log for the MDT, and there's a log for the client. And so figuring out which of those logs needs to get which of these commands ends up being a fairly complex function that's sitting there in the MGS trying to sort that out. Another problem is that the handler for these functions within the individual modules also needs to know about how the commands are called. So they don't go through the normal proc anymore. They go through this log update thing. So that log update thing now needs special handling in each of the modules. And some of these services don't have these handlers. Like, for instance, a big one is the LDLM. Right now, there's no way you can set a permanent parameter on the LDLM. Also, there's sub-services like MDS read page that don't have any handlers. Basically, anything under a hierarchy, with a directory hierarchy greater than proc fs Lustre, MDS/something, if there's another layer of indirection, basically it's not handled currently. So there's a lot of parameters that can't be set today. So how do we fix it? Proc's not going away. Let's use that original syntax, therefore. Let's create a single universal param config log. Let's make that same config log distributed universally to everybody. And let's, most crucially, let's parse it using the same parser that parses the current set param commands. So therefore, we can use globbing. We can use the same processing paths. We don't need to use the MGS now to figure out, in that complex function, to figure out what file to add the configuration to. and we don't need to add these special handlers. In order to figure out which nodes your particular command may apply to, you just use the appropriate globbing. So if you want to change the OST parameter, then you'd say OST star, and anything that doesn't have an OST proc file will ignore it. So we landed this in Lustre 2.5. So now, if you look at the difference between these commands, the temporary way to set a parameter and the permanent way to set a parameter are the same. We even said, hey, let's use the same command. Add an option to it. -p means it's permanent, and without a -p, it's not permanent. So we're doing this via an upcall, as I said, to set param. It's the same kind of upcall that we use to do various other activities. An upcall just means that it takes, we go from Lustre kernel space to call a user space function, which is lcontrol. Okay, so that's how we improve it today. But where do we go from here? We still have problems. Configuration logs are still used, and the rest of those configuration logs, all that weird mumbo jumbo I was mentioning in the beginning, is all still there, and it's unclear what those all mean, and they're also not easily accessed. The only way to get at them is by dumping raw files out of your file system. So, and also in some cases there are some things you can't change, like it's very difficult to change a failover location, like a nid of a failover location. So what can we do to get rid of the rest of this stuff? We could get rid of logs completely. How do we do that? Well, there's a new feature in Lustre 2.3, which was imperative recovery, which basically tells the MGS to let the rest of the file system know where a service has started. So once you do that, you don't need to predefine failover locations. Predefined failover locations was one of the main reasons to have configuration logs in the first place. So if we don't need that, then the servers can just report their own locations whenever they start, and that includes the failover location. The MGS then reports that failover, that new location to anyone else, and we don't need to kind of predefine all this stuff. The MGS just needs to track who lives where. And then, so that's all of the services. In other words, all of the MDS and OST stuff is all defined in the MGS at startup time, effectively. And then the only other thing left over will be those parameters that we were talking about. And why don't, instead of having lcontrol set param-p, why don't we just have a text file that's easily editable that lives in etc lustre, file name .text, and have our all the configuration parameters just live there. Anyhow, that's what I think should happen. The reason that part is not happening is because there's a few weird problems with that. One is it's hard to know the difference when you change something. It's hard to know the difference between the old one and the new one, so it's hard to send deltas then to the servers. But I don't think this is unachievable, so that'll be the next step, I think, is to make this, get rid of the current logs completely and simplify this even further. Okay, and now for something completely different. So one of the other things that I wanted to talk about was some other functions that Xyratex was working on. Actually, don't know what time it is. But how much time do I have? Oh, plenty of time. Okay, good. So these are some Xyratex projects that are in progress right now that we're working on that may or may not be of interest to the rest of the world. I assume they are. One is pdraid, which is a function that we're adding to the Linux MD-RAID stack. pdraid is a parity declustered RAID where instead of RAID 6, that are striped on a set of fixed locations on fixed drives, you can you decouple the parity group from the number of parity from the number of parity blocks that you're using. So you can have 40 disks in a parity group and use, for instance, two sets of 8, RAID 6 8+2 drives within that group of 40 drives. And that allows you to kind of reorganize these things to get basically much better rebuild performance. So some of you that use software RAID would be interested in this. Those that don't use software RAID, this doesn't really help you any. T10 end-to-end is also a project that I talked about at LUG a few years ago. We're still working on this. It ends up being quite a slog because there's not a whole lot of T10 support in Linux today. So T10, for those of you that don't know, is T10 diff. It's the hardware CRC calculations that are embedded in disk drive sectors. So T10 enabled hard drives basically can add 8 bytes of checksum and other data to the end of every physical sector, and the drives themselves will verify that those checksums are accurate before they write the data, or they'll return an error code. So right now that exists in Linux only from the driver level, the Linux hard drive, disk drive driver level, to the drives themselves. So we're having to add that plumbing through the MD-RAID stack, which we use, and then up through Lustre OSTs, and then eventually we're going to add the inclusion of that T10 information all the way back to clients, so that we can ensure that client calculated CRC checksums end up verified by the disk drive itself. So that's kind of one of the long-term goal there. There are also various performance improvements we're working on. So there's some single shared file, small file, and NRS policies that we're looking at to see how we can improve these areas in general. The WNC is the Windows native client. This is something that came up at LUG earlier this year. The goal was, the desire was expressed by the LUG community that they really wanted some way to easily integrate Windows into their system. So we revived some of the work that had been done originally at Sun/Oracle. Xyratex had bought those software assets, so we now own those software assets. So we were looking at resurrecting that project. We are also continuing work on developing Xperior, which is a testing infrastructure that provides a lot of utility to us in terms of testing. We also talked about this actually at LAD last year, and there was a cry out at LAD for us to open source this, which we did. And then various other Lustre internal improvements. That's the blue on the side. There are various bugs that we're including in our various Lustre internal improvements. So just a bunch of different small cleanups that we've discovered along the way. That's it. We'll make this short so we can all go to lunch. I'll still give you a chance to ask questions if you'd like.
So going back to the MGS not needing to differentiate the targets idea you kind of put out.
Yes.
I just can drop this image from my mind where you have this cluster with 100,000 clients, and then I want to send a permanent parameter for just MGS, for just MDT for something. So I insert this config log, and it gets distributed to 100,000 clients or rather, the lock is cancelled on 100,000 clients, and they all come rushing to the poor MGS trying to see, hey, what's changed in the parameter, and then they all discover, okay, never mind, I don't need to do anything. But at the end of it, MGS is probably just melt on the floor.
Yes. So, so Shadow actually brought up that very point when we were first doing this design. That's true. The way this is currently done is the exact same way, by the way. So it's no worse than we do today. What happens today is the log. There's a client log in particular, as I mentioned before. So that client log, if you cancel the lock on that client log, the code on all of the MGCs has a delay, a random delay added to it. So it's some small number of seconds. So that helps distribute the load over time to the MGS. But if you changed any parameter on the clients, you would still end up with that massive reload of the locks. So the difference between that and what we just landed is that now if you change a parameter on the OST, you would get the same reaction from the clients. So since there's a single config log instead of a config log per OST, you'd get that same. All of the clients need to get the new logs. But the thought is the difference between getting logs for 100,000 clients and getting the logs for 100,000 clients plus 1,000 servers isn't that big a deal, right? The difference between 100 and 101, well, it's not gonna break the bank. Anything else?
How are you planning to use T10 information in production? You know, it's great that you can sort of do this end-to-endness, but really using this.
So the original T10 DIX standard, that's data, DIX stands for Data Integrity Extensions, provided the ability to add that CRC calculation to applications. That was the original goal, is the applications themselves would calculate the T10 information, the CRC calculation. But this rapidly became very confusing for Lustre because with Lustre, you're not talking about known blocks that arrive at particular parts on disks, right? So with 512 byte blocks, disk blocks, you would have 8 bytes of CRC data. Well, okay, that's fine for all of the disks that you have that happen to have 512 byte data. What if you're writing into some random offset in there? Now, how do you calculate where those begin? And what do you do, especially with a clustered file system or a file system made up of more than one drive? What do you do, especially in the case where your block size may differ? So there's 512 currently today. There's 512 byte blocks, and there's also 4K byte blocks. And how do you distinguish between those? And we're certainly not going to pass all that information and expect the users to know how to calculate the right size data. So instead, our thought is we're just going to stop at the Lustre client. So we'll have Lustre do it. So Lustre will tell the clients the size of the sectors on the individual OSTs. So we'll report that information back to the clients, and then the Lustre client will calculate on a per OST basis those checksums, and then send. It gets sent as a separate packet of data. So we're not adding it to the data DMA. It's sending it as a separate DMA, and then scatter-gather handler in the OST will pass it down basically to the level that where the disk driver has to take those two lists and interleave them onto the disk.
regarding the PD RAID, so you want to be able to get a number of drives involved in rebuilds, right? And that's one of the big benefits of it when you go
Yep.
beyond like just a traditional 8+2. But then you hit limits in terms of what file system size you can support within LDiskFS. How are those things going to be reconciled? Is that an issue?
Well, so yeah, so I was saying, well, you could take 40 disks in a PD RAID system, and Galen's saying, well, if you have 40 disks in a PD RAID system, you can't stick that in a single giant ext4 file system because the ext4 doesn't scale that large. That's true, but there's no need to have them all in a single file system. So you could have, yeah, you could have each of those, you could have those virtual 8+2 arrays that were actually their own different file system. So you'd have individual OSTs that were part of this PD RAID pool. All right, lunchtime.